Hello, welcome to Bankram Cindy videos. This video is to help SHS, especially the final year students, to read and make this effective because of this pandemic. I hope and I wish that you will take this serious. Okay, so today we'll be talking about the binomial probability distribution. So what do we understand by probability? So probability from first first year, we saw probability to be probability of an event is the same as the number of the event over the sample space. So this is what we know from first year. All right. But for this session, we'll be talking about probability in a different area. So first of all, I'll introduce you to some parameters: mutually exclusive, at least, at most. I hope you can see. Yeah, I know you can see. And the formula, I've written the formula already. Complement set. Okay, so for mutually exclusive, if something is mutually exclusive, it means both, let's say A and B are mutually exclusive. That means A occurs only, B occurs only. So both of them can't occur at the same time. That is mutually exclusive. Hence, there is no intersection. Let's go to at least. So let's say S is at least 4. It means that S starts from 4, 5 upwards. So at least is the least of the numbers of S is 4. Now let's go to at most. At most is, for example, X is at most 3. It means that the highest number of S is 3. So S starts from 0 or any other number up to 3. It doesn't exceed 3. Okay, let's go to the complement set. From our previous studies in our basic schools and other, we remember that P of A plus P of A complement, it can be C or the prime, is equal to 1. So if I want to find P of A complement, is the same as 1 minus P of A. So probability of A. All right. So these are the things I want you to note. The formula for probability of an event, which is number of events over number of the sample space. Then mutually exclusive, and I give example as A and B. If A and B are mutually exclusive, it means both of them can't occur at the same time. So A occurs only or B occurs only, but both can't occur at the same time. Then we went to at least, and we said at least, if S is at least 4, it means that the least number for S is 4. So 4 upwards. Then at most, S is at most 3. it means the highest is 3, so it starts from the lowest to 3. Then we went to the complement sets, and we saw that P of A plus P of A complement is equal to 1. So finding P of A complement to be 1 minus P of A. Okay. So let's continue. So from here, you will see something called combination and permutation. So what is combination? They are all, so both combination and permutation are for selecting a number of objects, a number of events. But then combination has no particular order. Permutation, it follows an order. That's the only difference. And for the combination, the formula for combination is, so it's R n factorial n minus R factorial n factorial. X factorial. Okay, here I used R, so I'll make it R, sorry. So this is the formula for combination. You can also use a calculator. So for the calculator, you go to shift. So you can actually type your number. Let's say n equals 5. R equals 2. So for the calculator, it's 5 shift, then the division sign, then your 2. So it's 5 shift, the division sign, and your 2. Okay, let's go to permutation. Actually, permutation, we won't really be needing it. Okay, we won't be needing it, so there's no need for me to go over. So I just wanted you to see the difference between them. So now we know. Let's go to the main problem for today. So as I said earlier on, binomial probability distribution. I hope we are all following. Okay. So let me give you an example. Then we go through. Later I'll give you one, you solve, then you compare with mine. I hope you all get it. So for example, example 1. A bag contains 30 balls, which are identical. Except for color. Twelve of the balls are red, 18 are blue. 4 are picked at random out of the bag. What is the probability that I, they are all red. I, they are of the same color. I, 2 are red, 2 are blue. So we will solve it together. So solution. All right. From the question, we saw total number is 30. Number of red, 12. Number of blue, 18. But before we go further, we know that from probability, or is the same as sum, and is the same as product. I hope you remember this. Okay, so let's continue solving. So the first question was, what is the probability that they are all red? So probability that the ones chosen, let me make it a random variable x, are all red. I told you that combination is NCR. So here are N. For the red is 12. Then our R is our selected number of balls, which is 4. Alright, let's go to the formula. So probability that all the selected balls are red is the same as number of events over the sample space. From here, the sample space is equal to the total number of balls in the bag, which is 30, combination, the balls are 4. Now let's go to the number of events for this particular question. So N of E is equal to, here our N is 12. Combination R, they said all of them are red. And how many are we selecting? 4. So the whole thing will be 12 combination 4 over 30 combination 4, which is equal to 11 over 609. Here you should use a calculator because it will be too long when you are using the formula itself. I hope you are going by it. So let's solve the II. The II says they are all of the same color. So that means you can get all to be red, or you can get all to be red, or to be blue. So how do we solve it? I hope you can remember that we've solved the all to be red, and we had what? 11/609. So our next task is to solve for all our blue. So let's go to all our blue. Probability that X all are blue. So from here, still with the formula, we know our sample space will be 30 combination 4. And our events, we know the number of blue balls are 18. So n, which is 18 combination, we are selecting how many? 4. Alright, so here we will get 18 combination 4 over 30 combination 4. So in all, we are going to get 68/609 plus that of the red. We've already solved it in the previous one. So 11/609. What are we going to get? We just add the numerators. The denominator will still be the same because it's a common denominator. We add them, get 79. So this will be our answer. Let's go to the last question. 2 are red. Probability that 2 are red and 2 are blue. So from the second one, we saw they are of the same color. So the 4 that we are selecting can be either blue or red. But then this one, it's 2 of them are red, 2 of them are blue. So 2 of them are red and 2 of them are blue. And I told you that and in probability is multiplication. So let's go on. So we already know the formula. NE over NS times NE over NS. I hope you're understanding here. So we will get for the reds. The number of reds were 12. So 12 combination the 2 over 30 combination 4 is still standing times then the number of blues was 18, so 18 combination 2 over 30 combination 4. Then we are going to get 374 over 1015. This will be our final answer. Okay, so I'll give you one question to solve, and I'll give you the right answers. Okay. Example 2. In a class of 12 students, 9 are boys. If 2 students are selected at random, what is the probability that they are I, boys, I, girls? Alright, so I'll give you some minutes, then you solve. I guess you are done. Okay, I'll use a different color for this. So, solution. I hope you can all see. From the question, we have our total sample space to be 12. I hope you can all see. Number of boys, 9. Number of girls will be 12 minus 9, which is equal to 3. So the question is, if 2 students are selected at random, what's the probability that I, boy, so probability oh, this is too much. All right. So, probability for all to be boys will be equal to 9 combination. We are selecting 2. So 2 over 12 combination. We are still selecting 2. So you have to get this to be 6 over 11. For question 2, I insert probability for all girls will be the number of the girls, and here we are using combination, so 3 combination 2 over the total, which is 12 combination 2. You get 1 over 22. Imagine I gave you I, which is probability of a girl and a boy. So a girl and a boy. This will be the number of girls is 3, so 3 combination 1. So it's 1 boy, 1 girl, sorry. So that means the girls who selected 1 from the 3 times the 9 of the boys who selected 1 all over 12 combination 2. Nine over 22. Okay, so we've gone through some examples of this. This is just combination part. You may see this in the next coming video. All right, thank you. Bye.